Hello my friends, I am Dr. Sirajul Faisi. I welcome you in my YouTube channel. Today in this video, we are going to learn about cyclic voltammetry. So, what is cyclic voltammetry? First, I will discuss about introductions. You know friend, voltammetry from discovery of polarography in 1922 by the chemist Jaroslavl received the 1959 Nobel Prize in Chemistry. The earlier voltammetric method experienced a number of difficulties, but after in 1960 and 1970, significant advances were made in all areas of voltammetry, theory, methodology, and instrumentation, which enhanced the sensitivity of analytical methods. So, the common characteristic of all voltammetric techniques is that they involve the application of potential. I repeat, the application of a potential to an electrode. Second, the monitoring of the resulting current I flowing through the electrochemical cell. In many cases, the applied potential is varied or the current is monitored over a period of time. Thus, all voltammetric technique can be described as some functions of E, I, and T. So, governing law, Ohm's law, E is equal to IR. So, how it is working? You can see a voltammetric cell consists of 3 micro electrodes. They are, you can see, N2 purge line, auxiliary electrode, reference electrode, working electrode. And if you want to stir, then you use stir pump. If you want to purge nitrogen, say you need nitrogen cylinder for purging nitrogens. Now, another hand, you can see the arrangements. In original picture is like that. One is working electrode, reference electrode, and auxiliary electrode. So, what is the functions of working electrode? The working electrode are of various geometries and materials, ranging from the small mercury drop to flat platinum disc. Now, mercury display a wide negative potential range because it is difficult to reduce hydrogen ion or water at the mercury surface. Its surface is readily regenerated by producing a new drop or film, and many metals ions can reversibly reduce into it. Other commonly used electrode materials are gold, platinum, and glassy carbon. Now friend, auxiliary electrode passes all the current needed to balance the current absorbed at the working electrode. Now friend, reference electrode. The reference electrode should provide a reversible half reaction. With behavior, its only role is to act as reference in measuring and controlling the working electrode's potential. So the most commonly used reference electrode for the aqueous solution are the Calorimeter electrode. So these are the instrumentations. The basic component of modern electroanalytical system for voltammetry are a potentiostat, computer, and electrochemical cell. So these are the picture. The minimum potential required to initiate the electrolysis process is called the decomposition potential. The Faradic current is the current generated by the reductions or oxidation of some chemical substance at an electrode. Capacitive current, also called non-Faradic or double layer current, does not involve any chemical reaction, charge transfer. It only causes accumulations of electric charges on the electrode and in the electrolyte solution near the electrode. The limiting current is the in electrochemistry is the limiting value of Faraday current that is approaches at the rate of charge transfer to an electrode is increased. The limiting current can be approached, for example, by increasing the electric potential or decreasing the rate of mass transfer to the electrode. So the potential at which the current is one half the limiting current is called half wave potential, E half. it is represented by, very important for scientific paper. Diffusion current is a current in a semiconductor caused by the diffusion of charge carrier, holes or electrons. My friend, what is the RCD? A residual current device or residual current circuit breaker is a device to quickly disconnect current to prevent serious harm from ongoing electric shock. So, cyclic voltammetry, an electrochemical technique which measures the current that develops in an electrochemical cell under condition where voltage is applied. Cyclic voltammetry is performed by cycling the potential of working electrode and measuring the resulting current. Governing law, Ohm's law. So you can see the Faradic current, IPA, IPC, EPA, EPC. So EPA is the energy, IPA, IPC and EPC. Potential, you see the capacitive current, background, cathodic reduction, negative current, anodic oxidations and cathodic reduction. So what is the theory behind it? The applied potential controls the concentration of redox species at the electrode surface as described by the Nernst equation. So here is the meaning. You know the E is equal to E naught minus RT by NF log oxidation reductions like that. This is the del EP is equal to del EPA energy of PA minus EPC is equal to 0.303 RT by NF. So the formal reduction potential E naught for a reversible couple is given by E naught is equal to EPC plus EPA divided by 2. The reversible reaction concentration is related to peak current by Randless expressions. So IP is equal to 2.686 into 10 to the power 5 N 3 by 2 AC naught D half VR, where IP is the peak current in amperes, A is the electrode area, Cm square, D is the diffusion coefficient, 0 is the concentration in mole per cubic centimeter, N is the scan rate, like that. So this is the cyclic voltammograms. So irreversible oxidation or reduction activated over potential. Extra energy applied to the electrode in the form of increasing potential. My friend, reversibility depends on the relative layer of electrons, transfer rate constant, and the rate of change of potential is given. If the ratio Ks by N is small, then Nernstian concentration cannot be maintained. Then the process is called quasi-reversible. You know, friend, quasi-reversible process is characteristic by DEP greater than 59.2 per MV with the value increasing with increasing M. So, what is the applications of cyclic voltammetry? CV is rarely used for quantitative determinations, but it is widely used for the study of redox process, for understanding reactions intermediates, and for obtaining stability of reactions. So my friends, I hope this video will be helpful to you. If you like this video, then subscribe my channel, and thanks for watching. These are the references